All right, so for CO2, remember it looks like this. Okay, sorry, bad drawing. All right, so remember we have CO2. It has two domains, so it should be 180 degrees. sp3 only works with tetrahedral. sp2 works with trigonal planar. And so we're going to need something here that works with linear. That would be called the sp hybrid. So that's going to require the s and 1p, hence sp. 1s, 1p. With that, you're going to get two equivalent orbitals called sp, and his name is sp. So again, it's like mom, dad, enter in as two separate orbitals, and they create two separate orbitals, but they're identical now. Those are the children orbitals. Okay, the two p orbitals that we didn't hybridize over here, they didn't get to drop in energy, so they remain higher in energy and they're left unhybridized. You'll remember in the sp2 model, that allowed for pi bonding above and below the axis. So look at the molecular orbital diagram, and you can see the linear lobe right here on carbon, and then the unhybridized py and the unhybridized px. Look at oxygen. Oxygen has 1, 2, 3 domains. So they've showed him with the 1, 2, 3, sp1, sp1, sp2, excuse me, this is sp2, hybrid. So it's trigonal planar, and it has the unhybridized p orbital sticking upright. That, right there, can pi bond. That's the py bonding with the py. And then the pz on the other oxygen, because he's also got 3 domains, so he'll also be sp2 hybridized. He has a py, or pz, my pardon, a pz that can overlap with the pz on the carbon. So the py overlaps the py, the pz overlaps the pz, and because both of them are above and below the axis, it's 2 pi bonds. This is called a sigma bond. There are other hybrids that they thought used to exist. They used to believe in, look at the summary diagram over here, they used to believe that in order to get trigonal bipyramid, that this would require hybridizing the d orbitals. And to get octahedral, it would require hybridizing the d orbitals. So sometimes you'll see sp3d and sp3d2. That means they hybridized the s and all 3 p's and a d orbital, one of the 5, or this one, 2 of the 5. Scientists now believe that this isn't how it works, so we don't have to teach this in AP chemistry anymore. This is what you guys need to be able to do. So let's do an example together, and you'll see that even though this was complicated, we don't have to do anything that difficult with it. So let's come up to this example right here. Look at the bond counts, look at the sigma counts. If you have a single bond on a molecule, you can be assured that that single bond is caused by a sigma overlap. If you have a double bond, it is caused by 1 sigma and 1 pi. And if you have a triple, it's a sigma and 2 pi. I'm going to give an example molecule, and we'll go through it together for you to see what you're expected to do. So let's say I have a carbon bonded to another carbon, double bonded to a carbon that is single bonded to 2 hydrogens. This one has a hydrogen coming off of it. And for kicks and giggles, let's make this guy over here bonded to a nitrogen that triple bonds. So take a look at my structure. Every time you see a bond, count a sigma. 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma. I'm very tired, so let's count again. 1, 2, 3, 4, 5, 6. This has 6 sigma. Every time you see a double bond, count it as a pi. 1 pi. And every time you see a double, count it, or triple bond, count it as 2 pi. So 1 pi, 2 pi. So this has 3 total pi orbitals. So I'm just basing it on this pi count. Double bond is a sigma and a pi. And so we counted 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 sigma, and 1, 2, 3 pi. That's all you have to do for sigma and pi counting. Now let's talk about how you get the hybrid. So let's label this carbon number 1. Count his domains, 1, 2. Subtract 1 from that. So it's count of 2 domains, that would be sp hybrid. So the p count is always 1 off your domain count. If my domain count is 2, the p count is 1. So this carbon number 1 is sp hybrid. This carbon has 1, 2, 3 domains. Let's label him carbon number 2. Sorry. Carbon number 2 has, oh my gosh, I'm so sorry. This is carbon number 2. Carbon number 2 has 1, 2, 3 domains. Take 1 off the domain count to get the p count. 3 domains would be sp2. So the domain count, if you just subtract 1 from it, you get the p count. 1, 2, 3 domains minus 1 gives me sp2. I want you guys to now work on the worksheets that you've been given and try your best, and I'll give you the answers to those worksheets as the days progress. I would like to be able to give you a quiz on this by Wednesday or probably Thursday, given the circumstances. By Thursday, so put your questions up on Edmodo, and I'll be glad to answer them.